few weeks. Also, thanks to Kent, we made a lot of progress in the translation progress. Mainly because now having the debugger run with Rosette, it's way easier to actually understand what the code's doing and not translating things in isolation is really good. And yeah, GDB. So yeah, the last thing I did was translating do XMIT.
It was about right here. It is not. I erased it.
Oh, dang it.
Well, there.
Oh, no, the
So
detailed picture was called.
Greg wrote Rosette, which was a VM. It was implemented in C++. It was about 30 years ago. Yeah. But yeah. Mark and others. Sorry, Greg and others did that. Then the initial effort was to translate that from C++ to Scala, and then integrate with all of the other things that are available in the ecosystem of the JVM.
Okay.
So we've got a wrapper, at least for LMDB, and we've got stuff written in Java for the networking layer. And the nice thing about Scala is that there's at least some chance, some hope of formal verification given the type system that's so much better than Java. It's not quite as good as some of the more esoteric languages out there, but they don't have the ecosystem to support them. So what Roscala does is take the Rosette base language that is output from the compiler that Kent wrote. So you take Rolang, you compile it to RBL, and then that is the interpreter for that Rosette base language.
That helps.
Sure.
So now they're going, they sort of broken down. They've broken down the translation of each of the opcodes for the virtual machine. So when Tim talks about do XMIT, he's talking about the interpretation of the actions to take when the VM hits that opcode.
Yeah, you guys are better at explaining that, I guess. One more update I can give is that now we can define primitives. And yeah. So opcodes is basically a mechanism where an opcode can call a primitive and that does something. Is that okay?
There are about 30 opcodes. What they do is load things into memory. But one of the opcodes, for example, loads plus into a register, and plus is a primitive. We have things that less than or equal to. All of the comparison operators on the fixed point and floating point numerics, all of the foreign function interface codes that load up a library off of disk and pull out the relevant symbol. Anything that is more complicated than... Anyway, primitive is a chunk of straight-line C++ code that the VM can load up and invoke.
So you're using primitive in the language sense of primitive? Yes. And then is there a one-to-many, there's probably an end-to-end relationship between language primitives and opcodes?
No.
So there are about 30 opcodes, but there are 350 primitives.
Okay, so in C++, you can have a plus is one, should go one opcode, but plus plus, which is an atomic operation, which plus isn't necessarily, right? Because it goes to plus can.
Yeah, these are not tokens. These are chunks of code that can be run, and each one has their own symbol, their own token that goes with it. So it's not characters, but they get assembled into tokens like fx minus equals is the fixed point less than or equal to operator.
Rosette exposes a number of operations as primitives in the language, right? And they're not necessarily going to map one for one into the implementing language, whether it's C++ or Scala or whatever. It's just that's what Rosette says your computational universe looks like. And then the opcodes correspond to how you can assemble, compute, starting with those primitives.
So in one sense, you can think of primitives as being the built-in library that the VM is able to call on, and the opcodes are how those calls are issued.
So one conversation that we're going to have very, very shortly is cryptographic primitives and how that might relate to opcodes that are extensions of the existing VM.
Relate to opcodes.
So we might, for example, have opcodes that are effectively, that record as, rather than just have a bunch of cryptographic primitives, and we just use the opcode apply prim, we actually have special opcode for the application of digital signing, for example.
That's possible. We still have to work out how to keep track of which cryptographic primitives we're actually using, especially if we have to end of life one and use another.
Yeah, exactly.
Upgrading these. So building it in as an opcode would mean that we would have to extend the VM again rather than add just a primitive, define a new one.
So, I mean, you could do both. You could have a digital signature opcode that takes a primitive.
Yes, correct. Sort of engineering question. You know how many tests there are?
Basically, we write tests for every opcode we add, and what else? I started writing integration tests. So basically, I start with an expression in Rosette, look what that compiles to, and use expressions as integration tests. So for example, +1, like an addition in Rosette, I take that as a starting point for a test, for integration test.
So there's dozens of them or hundreds of them?
I mean, we're just starting.
Right.
So not yet, but there will be a.
But there's another aspect to testing, which is that once they have the VM is really kind of the ground, and there's this whole boot layer of Rosette code.
Right. Yeah.
And that boot layer of Rosette code is going to be a massive test suite for the VM.
Yeah, and you know, we inherited the C++ code, which didn't come with a test suite, other than, hey, it works on this boot.rbl. So there's no gold standard to compare it against. So we're trying to write tests for what we think this ought to do and make sure it works. Yeah. And when we get to the RBL, that'll be an enormous amount more that we'll be testing it against.
Just sometimes I like it. Sometimes I grab the code, some code, download it, compile it, and run the test, and just yeah, just for fun, you know, whatever.
No social.